The mysteries of relative humidity have been puzzling technicians for millennia. Some believe that reheat removes humidity, others believe that low temperatures introduce humidity. Don't ask me who, but trust me, I've heard it out there on the field. Today, I got a perfect example that will exemplify why neither of this is true. Let's talk about it. Here we have 2 cups of water, each holding exactly 6 ounces of water. But as you can see, this cup looks much emptier than this one. This is going to represent our high temperature, and this is going to represent our lower temperature. Let's just say that this is 60 degrees and this is 80 degrees. What's happening here is that relative humidity is relative to the temperature. The higher your temperature is, the greater the amount of water it can hold. Therefore, 6 ounces of water on 80 degrees will seem like less humidity. Your relative humidity will drop, and your relative humidity will increase at a lower temperature. The thing is, I understand why there is sometimes a misunderstanding. In an area where I live, for example, during the summer, we have very high temperatures with very high humidity. And during the winter, we have lower temperatures with sometimes very low humidity. So let's say you have a hospital, for example, like the one I had today. During the summer, they'll complain that the temperature is low, but the humidity is very high. That's because the overall amount of water vapor in the air is higher. So we need to deploy the reheat in order to be able to continue to cool the space without overcooling it. What the reheat is doing is just raising the temperature of the supply air so it doesn't overcool the space while your cooling coil continues to dehumidify. Vice versa, in the example I have for you today, we had a very high temperature in a room that they needed to be at least 90 degrees, 80 to 90 degrees, but the humidity was very low. That's because the overall humidity in the air was much lower. There was much less water vapor in the air, and thus by raising that temperature, your water vapor seems like less. That's why I'm using these cups. When you raised it to 80 degrees, now your 6 ounces of water look like half the cup. And when you lowered it to 60 degrees, it fills up all the way almost to the top. It's the same thing happening, but in the air instead of a cup. This is why it's so important to understand that RH is relative humidity, and it is relative to the temperature of the air. That's what we're measuring for. We're not measuring total humidity. We're measuring relative humidity. Just to add a little nugget of wisdom to the scenario I just presented, the only way to fix that would be to introduce humidity into the space. You can't fix that with your HVAC alone. To remove humidity, you can, because you could take advantage of the cooling coil to remove humidity, but to introduce humidity, you need to have a way to introduce some sort of water vapor into the space. And that's it. A very short video talking about HVAC and relative humidity. Hope this helps you out.